Hello, my friends. This week we will continue the present worth analysis, part 2, right? Uh, what we saw last week, we did it present worth analysis for same useful life, and we solved couple examples for this one, and we jumped to the for different useful lives, and I gave the introduction of the concept of for different usage life concept, but I didn't solve any question right now. For today we will start with one example and then we will continue, but let me remind you what we saw first, then after that we will jump to the question and then we will continue for uh, what is the other one? Indefinite, right? Indefinite. Like, let's show like life of usage life, so like bridge and roads. Okay, so as you remember, I show you guys two different options. If we have like for like 5-year duration and the other one is 10-year durations, different options, what we need to do, like we need to bring the least square options. I gave a brief introduction about this different usage and then find the mutual date in order to compare these two. Then what did we do? We go through like this for 10 years and 5 years speed and allied, two different alternatives, and then we said if we want to compare this one, we are comparing like apples and orange, which means it's totally different. We cannot compare this one, so we need to make it in the mutual date, so we can compare apples to apples and orange to orange. Yeah, like after we did like in 10 years, both of them, 10 years speed is 10 years allied, then we compared, as I showed in the last um, lecture, and we know that the period can be short, intermediate length, and indefinite length, and we stop over here. We know that this least common multiple idea, which we bring 10 years, or we talk about a little bit about the terminal value idea. This terminal value idea is like, let's say one of them is 5 years and then the other one is 10 years, right? Let's say 7 years is the terminal value of the project, so we need to taking care of this terminal value in order to analyze these two concepts. Okay, let's go through the examples in order to understand, in order to better understand this concept. In this example, we have different useful lives. One of them is 7 years, the other one is 13 years, but we are using a method of terminal value. So for 10 years, end of 10 year, estimated market value is, and the alternative one is 20,000, alternative 2 is 15,000. And it's given also the alternatives. The first alternative, the initial cost is 50,000, second alternative 75,000, and estimated salvage value, which is end of this useful life, is the one is 10,000, the other one is 12,000. If it finish in 7 years and if it finish in 13 years, as you see here. Okay, let's write it down net present worth. How we are gonna calculate this net present worth for the this is alternative 1. There is initial cost which is minus 50,000, right? Then plus we have 10,000 at the end of 7 years, right? Because we finish up in 7 years, so we are gonna sell this product at 10,000. So it's gonna be benefit for us. It's gonna be, we are gonna convert it to present value from the future value, and the interest rate, let's take it as 8% again. 8% for 8%, let's say, and 7 years. We need to sell it, so it's gonna be benefit, but we are gonna finish it in 10 years because our terminal value is 10. So let's need to buy another 50,000. Let's say this value doesn't change, 50,000. Then we are gonna buy again, as I said. But when is 50 years later we are gonna spend? So it's gonna be P over F again. It's the same thing as this guy, 8% and 7 years. When we buy after 10 years is gonna be 20. We are gonna get 20 because it's not anymore salvage. It's the 10 years market value of this guy. So and second hand, 20,000 we are gonna get. So we need to multiply by P over F again, 8% and 10 years right now. Okay, we finish up the alternative 1 for net present worth. Net present worth, the second alternative, if we take the first thing we are paying is 75,000, which is cost, so it's gonna be minus. Then estimated salvage value of useful life is 12,000. However, it doesn't finish because the useful life is 13 years, but our terminal value is 10 years. That means we just need to add, instead of 12 years, we are gonna add just 15,000 when after 10 years. So it's gonna be P over F, 8% again, and 10 years. So by looking the tabular values, let's calculate it. This net present worth, the first net present worth alternative. So it's gonna be again 50,000. Then we are gonna add 10,000. Let's regroup of this one because the coefficient of these two is same, so it's gonna be minus 50,000. And we need to multiply P over F 8, 7. We need to look at our table, and when you look at, you are gonna see 0.5835 and 0.5825 as a coefficient of P over F 8 and 7. Then we need to add 20,000 by P over F 8 and 10. So it corresponds to 0.4632, 0.4632. So if you add all these guys, you will end up 64,000 0.76, but minus. So for the first alternative, we are gonna pay $64,076. Let's see the our second alternative, like how much we are gonna pay for this value. Let's say net present worth of second one is 75,000, is gonna be minus, right, plus 20,000 and multiply by, let's see the coefficient is 0.4632, 0.4632. So when you add each other, you we can end up 60 let's see 68,052, 68,052. that is also minus. Let's see the first and second, which one we are gonna prefer, alternative 1 or alternative 2. Alternative 1, we pay total of 64,000 some stuff, and alternative 2, we need to pay 68,000 some stuff. So either I will buy the I'm gonna pay 2 times of machine or product, even though like I buy 2 times, alternative 1 is, as we see, is better option in 10-year permanent terminal value and 8% of interest rate criteria.
The last one is infinite length analysis periods. It's also called capitalized cost. Sometimes the analysis period is of indefinitely length, and the need for roads, dams, pipelines, etc. is sometimes considered permanent. So we use, like when we do some infrastructures, we don't consider like you have a short timer period. We are saying infinite length till you like demolish these buildings, right, for the pipelines or dams. Like we reinforce and then we keep on stable. And in this situation, a present worth analysis using an infinite analysis period, present worth analysis in this case is called capitalized cost. So capitalized cost is the present sum of money that would need to be set aside now at some known interest rate to yield the funds needed to provide a service indefinitely. All right, and if we go through the other one, okay, like here as we see, present worth with infinite analysis period, we are gonna use P, which is the capitalized cost, is equal to annual service payment over the interest rate. So this is very simple formula. We are gonna use it every year. How much we need to pay divided into the interest rate, let's say like 7%, which we will divide with 0.07, and we are gonna get the capitalized cost. I will give you very basic example for this one. Let's say the fitness salon, fitness center, they are offering you guys the infinite length of membership. So they use this, basically they are using this formula in order to make you to pay right now, so you will make it the infinite access to go inside this kind of centers. So like instead of every year how much you are gonna pay, they are gonna make divided into the interest rate, and they are finding like how much you need to pay, and instead of you are paying every year, you will just want to pay one time, and you get the golden membership. But the problem is they are making like they made this formula. They see the less amount they are gonna get. They put some other amount for their interest, which you don't realize, and you pay it, and it seems you pay less money, but in fact you are paying more than what is need to be. All right, let's solve more examples, then we will just figure it out like how this one works as well.
In this example, we are gonna simulate the capitalized cost. Let's write how much. I'm gonna put these guys here in order to write it better. How much should one set aside to pay $50 $50 per year for maintenance on a gravesite if interest is assumed to be 4%. So let's say you have one relative and then you don't want to deal with the gravesite, but you want to make it in order, and you just want to pay one time, and then you set like how much is gonna be for the entire duration. So he said like if you pay me like $50 per year, I'm gonna check it out, but you don't want to like pay him like yearly. So you said like just give me one stuff, and I don't want to visit anymore. Blah blah. I don't know. Then like how much you need to pay? What was our capital cost formula? It was P is equal to A over I, right? A over I. So A is $50 and I is 4%, which is 0.04. So when you divide to each other, we can get 1,250. $1,250. So if you pay one time $1,250, so is it like watering or irrigation or like some other maintenance stuff is gonna be taken care of the by the officers or who is responsible in the gravesite. This is the case. Let's say we have a case that a company, like the government, one country's government, made a deal with a company for the highway, and for this highway, this government need to pay for the initial cost of 8 million. Then after 70 years, they need to pay again 8 million. Then every 70 years, they need to pay 8 million. So we are going to calculate it. What is the capitalized cost of this one? Like what they need to give at once at the beginning, so the maintenance and this road is going to be permanent for this country. Let's take 7% of interest rate, or I like 7% of interest rate. So we know that this one is 8 million. Our P is equal to A over I, right? We know this capitalized cost formula. But what is this A? A is the annual series. This is not annual series anymore. This is like 70 years, 70 years, 70 years. So what do we need to do? We need to divide it into 70 years. So like we need to take this 8 million into this 70 years. What we need to do, we are gonna say A is equal to uh, 8 million multiply by, this is the future value, right? Either you can start with it from here, but we have this principal amount, so we are gonna stuck with this principal amount. So from future to the like separate into this cash flow diagram. What we are gonna do, we are gonna see the annual series over future value of this 8 million is gonna be cancelled. 7%, how many years? Yes, 70 years. So when you take this guy, you will find it is 4,960 $4,960 every year it need to be given. Then for capitalized cost, we first paying 8 million plus every year 4,960 over because we find the I is 0.07. We are gonna divide it into 0.07. So at the end, we will find it if we pay for this highway 8,071,000 dollars. So we will say we have a permanent cover with its what's that? With its the permanent lives, right? As you see, like 71,000 is very small amount of money. Of course, it's not making sense. Like, but we can see that 8 million. When we say okay, give us like 70 after 70 years, give us 8 million, is not gonna be the same thing. It's gonna be less amount, like almost 8 million. Like how much is gonna be divided into 100 times less, almost like 100 times less than right now. Power, money's power. For this 170 years, then after the 140 and blah blah, goes to infinity. It's gonna be like when we add, it's gonna be very very small money. Therefore, so of course, when you make your design, if you say 8 million right now, but it's right now, it's gonna be too much money. If you talk about like 10, 20, 30 years from now, we need to be very, very careful. We need to take maybe like 70 years later, another 8 million, or we need to make it like putting like some certain rules that it can cover us a good perspective. All right, let's jump to if we have multiple choices in this example. Let's put again 7% of interest rate. Let's put it aside and let's compare for this one for 5 years. What we have pipe sizes. If you want to install, design a network for a building. But when you compare, you need to take in care of initial cost plus cost of pumping, so it's hourly billing you because of the electrical energy what you consume. So for each terms, each pipe size, it has different uh, prices conducted. So let's try to find all of their present worth of cost. So let's see for 2-inch, right? 2-inch present worth of 2-inch pipe. The initial cost is 22,000, and cost of pumping is $1.2. So again minus, because it's a cost, 1.2. What do we need to multiply is, let's say we have, let's put 2000 operation hours. Okay, so 1.2 multiplied by 2000, and this per year, like operation hours. So let's convert it to present value from annual. So we know that 7% and 5 years, just plug. And present worth of 3-inch, same thing we are gonna do, is gonna be 23,000, is gonna be minus again, and minus the cost of pumping is 0.65 multiplied by 2000, again operating hours, and we need to multiply it from present from annual service to present value for 5 years in 7% interest rate. Same thing, present worth for the 4-inch and present worth of 5-inch is gonna be the same thing. Let's write it down. 25,000, again minus 0.5 multiplied by 2000, multiplied by this coefficient we are gonna check in the table, or you guys are gonna write your mathematical formula and you can find it as well. And the last one is minus 30,000, or if you plug if you plug the 5-inch pipe size in this building, we need to multiply by 0.4 hourly cost for 2000 operating hours per year, and P over A 7 and 5. Okay, we write it everything, and when we calculate for the first one is gonna be minus 31,840 dollars cost is given, and the second one is 28,000 minus 28,330 is given, and this one is minus 29,100 is given as a cost, and the last one is 33,000 minus 33,280 is given by the choice of these values. And as it's obvious, what we need to choose for this building is the less amount, less cost, is $28,330, which is the pipe size of 3-inch is suitable for our building with given values, the initial cost and cost of pumping. Okay, in this example again we have multiple alternatives. Let's try to evaluate these alternatives. Before that, let's write down the question. An investor paid an $8,000 to a consulting firm to analyze what to do a parcel of land on the edge of town he bought for $30,000. The consultants suggest 4 alternatives, as you see on the table. As you see in the table. If minimum attractive rate of return is 10%, so he's expecting to get 10% back if we do some these alternatives. What should he do? Like, if which one is question is which one in this alternatives, which one is more than 10% and which one is more, or all of them is less than 10%. We are gonna choose. Okay, so that's why we are gonna take the interest rate as 10%. So in order to do, we will evaluate. So let's go through for the first alternative, like A, present worth, or like net present worth, because we are looking the benefit. For A is 0 because he didn't spend anything. He didn't do let's take this $8,000 paying this consultant firm giving is as we see is a minus, but let's see it more. Like he already paid the 30,000, so we don't need to put these guys as a minus because we are gonna evaluate right now which one is giving the 10%. Net present worth of alternative B, we are gonna evaluate it. So what is it? So it says let's open a vegetable market, which is the total investment is 50,000. Uniform annual benefit is 5,100 and terminal value after like some years, and let's take it, this one is 20 years, is gonna be 30,000. Okay, so what we are gonna say, minus 50,000 because we paid, the guy paid right now is minus 50,000 plus every year he's gonna get 5,100 from this vegetable market. So it's gonna be P over A, as we say, is the minimum rate of return is 10%. So if I write 10% and 20 years, so he's expecting to get back in 20 years that amount of money. Then the terminal value of this vegetable market, if he sell it after 20 years, he can sell it for 30,000. So it's gonna be P over F 10% at 20 years, right? And let's see net present worth of C, option C or alternative C. What is it? Is a gas station. So they suggest to give 95,000 for the initial cost, and this gas station is gonna bring almost double 10,500 every year, and at the end he can sell this gas station for $30,000. Okay, let's write it down. Minus 95,000 for the initial cost, and he's gonna get every year 10,500. Again, P over A 10%, 20 years, and again 30,000 for future value, 10%, 20 years. Okay, and at the end net present value of D is buying a small model to pay initial cost of $350,000, and every year he's gonna get 36,000, like 6 times better than vegetable market, and like almost 3.6 times better than gas station. This one is 7 times, right? And he's gonna get 5 times better than this vegetable and gas station for the end value. Okay, let's write it down. So it's gonna be minus 350,000 plus every year he's gonna get 36,000 P over A, the same coefficient of U above many, and at the end he's gonna get 150,000 again P over F 10, 20. Okay, let me calculate and come back. Okay, the first alternative is 0, we know that. The second one is minus 2120 is equal to minus again 1140, and the last one is again minus 21 to 10. All right, when we compare which one is better, do nothing is better, because if we are thinking, or if the guy thinks 10% is the optimal, like, or minimum rate of return, as you take 10% interest rate for the, like, if you go through to the bank and if you pay your money to the bank for 10%, you will get zero value. You know, this is do nothing. But if you do some business like vegetable market, gas station, and small motel, you will earn less than what you are gonna get from the bank in this condition. That's why sometimes do nothing is the viable choice for economic analysis, economic condition. All right.